Hi, good evening everyone. Are you able to watch? Are you guys getting now? Yes. Are you getting? Are you audible? Guys? Are you getting? Are you audible? Hi, good evening everyone. Are you getting now? Hi, good evening everyone. Are you able to watch? Are you getting clear now, everyone? Voice? Are you watch? Are you getting clear now, everyone? Voice? So welcome to YouTube live classes. So today we'll start what in electrostatics only next topic. Okay, so for getting subscription and everything you can see the below description, you'll get the details and use you can code Kiran live for subscription. So in last class we have discussed about electric field due to an electric dipole. Electric field due to dipole, right? So in this class, so we'll continue that. Already electric field due to dipole we find. Electric field due to at a point on axial line of dipole and the equatorial line of dipole completed, and at any point also completed. What is that? At any point, electric field due to at any point on the electric dipole will be what means other than axial or equatorial. At any point, for finding we have the formula 1 by 4 pi epsilon naught p into root of 3 cos square theta plus 1 by r cube at any point. Actually, how can we get, see, this is electric dipole na, minus q and plus q, AB. So, at any point means, for example, if you consider a point from the center at a distance r, here the point P you have to consider. So, at this point, how to get the field? See, it is making angle theta na. So, it is in two dimension. Along, see, it is in two dimension means along this one component and along perpendicular one component. See, along the line, see, the dipole is making an angle na. So, in this direction, one component E1 and a perpendicular in this direction one component E2. So, the resultant is what? E bar. So, E bar equal to E1 bar plus E2 bar. What is E1 bar? See, along like axial line. So axial line along what 1 by 4 pi epsilon naught. What is the axial line equation? 2p by r cube. That is 2p cos theta by r cube. And E2 is what? Equatorial, like it is what? Perpendicular. Means it is like two dipoles. It is like what? Two dipoles. Okay. Like A2, B2. So 1 by 4 pi epsilon naught P by R cube and perpendicular sin theta. Okay. Now you can take the resultant. So how to find the magnitude resultant? Perpendicular to each other under root of E1 square plus E2 square. So substitute these two. You will get E will be what? 1 by 4 pi epsilon naught P into root of 3 cos square theta plus 1 by R cube. This is field due to at any point. See, suppose axial line theta equal to what? 0. See, cos 0 1 3 plus 1 4 root 4 means 2 2p by r cube, right? Equatorial theta 90 is 0 p by r cube. Like this we will get that. Now so that is field due to distributed dipole. And see, field due to quadrupole. See, generally we have different electric dipole also having what different types. Quadrupole, distributed pole. Okay, quadrupole and distributed pole. What is quadrupole? See, consider half ring. For example, see, distributed pole I will show you. Distributed pole. See, in this distributed pole, see, let us consider an half ring. So charge is what? Uniformly. So consider the uniformly distributed plus q. Okay, and another equal and negative charge is placed at the center at a distance or radius r at the center. So your minus q is what? Point charge, while plus q is what? Distributed on the ring. So this system is called what? Distributed pole. This type of system is distributed. This is like what? Semicircle. Half ring we consider here. So plus q is what? Distributed uniformly and minus q is placed at the center. So to find here field, you have to consider a small part. These are what? Radius, right? So consider a small portion. The small portion dq. See, it is making small angle d theta. Okay, now. So it's a dipole moment. The net dipole moment. The net dipole moment will be what? So the net dipole moment P net. What is the dipole moment here? Q into 2a. So how can we get here? P net means we have to take this small charge and we have to integrate. Okay. So along this means what? P cos theta. P net will be, we can write dp cos theta. So total means you have to integrate from 0 to what? Pi by 2. For if angle making is here pi degrees, then dp cos theta you can integrate from 0 to pi by 2 you can integrate. So you will get 2qr by pi into sine of pi by 2. Suppose see it is pi will be pi 180 sine 90 1. So in that case 2qr by pi. In this case ring. And again only 90 degrees means here you will get this. at some angle means this is. So this is general net dipole moment. Now for this semicircle means pi you can substitute 180. So sin 180 by 2 sin 91. So you will get 2qr by pi p net. Suppose if it is complete circle, then it will be what? Sin pi. Pi by 2 will be what? 180. So 180 means sin 180 is 0 now. So p net will be 0. Hi Fahad. Fine, fine. How are you? How are you, Fahad? Are you coming to classes now? My special classes? Are you coming? So come and join daily special class also evening 6 to 7. Evening 6 to 7. Are you there? Next, quarter pole. See. Quarter pole. So in this quarter pole, what it is combination of two dipoles. Means sometimes what two charges are what not concentrated at ends like water molecules, carbon dioxide. Okay, so three charges are arranged. Then we have to visualize that combination of two dipoles. So it means, see, for example, this is a system minus 2q, q and q making angle theta. So actually it is what, see, two dipoles, q minus q, q minus q. Here, see, the angle between them is theta. See, two dipoles. What is the resultant here? Resultant dipole moment, how can we find it? P and P, angle between them, theta. So root of p square plus q square plus 2pq cos theta. Equal magnitude means 2p cos theta by 2. So that is the direction, resultant. Or suppose, see, the system is like this. Q minus 2q plus q. So we can write it as what? Minus qq minus qq. So two separates are minus q, 2q minus q. Then we can write what? See, minus q, q, q minus q. Or we can write separately also, plus q minus q. Like this. We can find it. So this is what? Quadrupole. So like this we have different dipoles. Okay. And see, in axial line, k into 1 by 4 pi epsilon naught 2p by r cube. And on equatorial line, p by r cube. See, this is 2 into, so 2 times of equatorial line we can write. An axial line field equal to 2 times of equatorial line field. Or equatorial line is what? 1 by 2 times of axial line. Like this. We have to find it. And now see, if electric dipole is placed in a uniform electric field like this. Let us consider an uniform electric field. E. So in this an electric dipole is placed. See, electric dipole is placed like this, minus Q plus Q, A and B. See, it is placed in the field such that what it is making an angle theta with the field. So what happens, see here, force due to electric field QE force act. Here minus QE in this direction will act. So equivalent opposite forces act so that what it can rotates. So rotates means what? Torque will be developed. So the torque tau equal to force into perpendicular distance. So what is the force here? QE into perpendicular distance. So this is dipole length 2A. So what about perpendicular distance here? So this is the perpendicular, this one or this one, perpendicular distance. How can we get see sin theta equal to opposite. Let here give some n or here also dn bn by 2a adjacent hypotenuse. So bn equal to what? 2a sin theta. So it will be perpendicular distance 2a sin theta. See q into 2a p into e sin theta. So therefore torque equal to what? P sin theta. So in magnitude tau bar equal to P bar cross E bar. Torque due to electric dipole placed in a uniform electric field. You can write like this. Okay. Like this we have to find. So this is about dipole cases. So I am reminding some cases are there. So those cases we will discuss in tomorrow class. Okay, na? Are you there, Fahad? Where are you there? Are you there? So we are having classes daily from evening 6 to 7 p.m. and see from Sunday onwards morning 10 to 11. Marathon class is there. So you can join everyone. So to join use our code. See in the app you can use the code Kiran MSC 08 5140. So use this skill or Kiran P Live. Use this code. Capitals in capital letters you can use. You can enter into the class. For subscription also same you can enter. Sai Manikanta. Hi Sai Manikanta. Hi. Where are you? You are from? Hi Simon Kenda, you are from? See, tomorrow we will do problems based on this objective problems and different flux concepts for objective purpose. We will do in tomorrow class. We will complete in tomorrow class. Okay now. So we'll meet in tomorrow, right? Bye, all of you. Bye bye. Hyderabad? Okay. Are you coming to special classes? My classes? See, you can download Unacademy Learn app. Okay. So download Unacademy Learn app and proceed the process TS EAMCET and AP EAMCET. See, use my code for entering into class. Kiran P Live or Kiran MSC 08-5140. Use this code and enter into my class daily evening 6 to 7 evening. Now at 6 o'clock is there. Now I will paste the link here. Okay, I will paste link here. You can search my name Kiran Paniharam. You will get the link. And Sunday 10 a.m. to 11 a.m. marathon class. So join. We are discussing in that. Yeah, I will paste now link. So in that now I am discussing laws of motion revision. Are you there, Fahad? Okay. Right. So bye all of you. We'll meet in tomorrow class. Bye. Yeah, I have difficulty in solving numericals. Actually, I am explaining numericals also every day. Every day I am explaining numericals. Some concept and numericals are one day complete concepts. And next day completely numericals on that. Yesterday I have explained complete numericals on pulley concept. And today pseudo force concept problems. And then friction concepts and problems. So laws of motion is very important. Mechanics in first year mechanics is very important. In that motion in a straight line, plane, laws of motion, very important. Already first two completed with problems also completed. If you watch my previous videos you can understand. So don't miss, join this, because if you are perfect in mechanics and electricity, you will get maximum. Yeah, second year also no problem. First year revision only, this is completely objective revision only, not for IP. Up to mains, NEET and EAMCET every entrance. So for you already second year running, so first year it is revision. First year problems also very important, because in entrance both will come, first year and second year. So first year mainly mechanics very important. That's why I have started that. Yeah. And after this mechanics, after work energy power, I will start second year. Okay. Right. So today you can join. I will paste now. Bye.